This is a quiz that you guys took last week. I want to take a minute to review some of it with you. They were mostly pretty good, but there was a couple mistakes I want to look at. First, I think everybody did this one okay. Since frequency is oscillations per second, you just take 42 divided by 50, and you end up with the frequency in hertz, right? A hertz is a per second, so this was 0.84 hertz. Okay. To go from frequency to period, it's just the inverse. So frequency equals 1 over t, or t equals 1 over f. So if you just multiply that to the inverse, 0.84 to the negative 1 equals 1.19 seconds. Okay. The mass of the object, this is a little bit trickier, but not a whole heck of a lot. You can use either equation you like. Okay, it doesn't matter to me. I'm going to use frequency. Frequency equals 1 over 2 pi times the square root of k over m. Bigger the mass, the lower the frequency. Okay. Now, to clear this fraction, just multiply both sides by 2 pi. I had a lot of people try to divide by 1 over 2 pi, which you can do, but you've got to be very, very, very careful when you do that. Multiply by 2 pi, multiply by 2 pi, and so you can see I've got 0.84, right, my frequency, times 2 pi, and 0.84 times 2 second pi is 5.28 or 5.278. 5.278 equals the square root of k over m. Okay. Now I'm going to square both sides, squared, squared, okay, and so I get 27.85, and really that's 0.56, equals k over m. I'm looking for m, so I've got to multiply by m and then divide by 27.856. So if I take 139, my k, divided by that 27.856, I get 4.99 kilograms, right? Or m is close enough to 5 kilograms that nobody knows the difference. What effect would doubling the mass have on the frequency? Now, I was actually going for a number here, but you don't have to tell me the number. Okay, twice the mass means lower frequency. Okay, now how much lower frequency? Well, let's think about what we did. Okay, frequency is proportional to the square root, or 1 over the square root of m. I'm just doing a proportion, not an equality, which means if I take twice the mass, then I've got to multiply this side by this 1 over the square root of 2. So it'll be 1 over the square root of 2, my original frequency. Okay, or f divided by 1.414. Alright, 2, a spring stretches 12 centimeters when 200 grams is hung from it. The biggest problem we had on this was this says centimeters, this says grams. So m equals 0.2 kilograms, and x equals 0.12 meters, and so F equals kx, and this is F force, not F frequency. Okay, so F equals kx, so I get F, which is mg, 0.2 times 9.8 equals k times 0.12 for my distance. Okay, so 0.2 times 9.8 is 1.96, and if you divide that by 0.12, you get 16.3. Okay, so 16.3 newtons per meter. Stop forgetting units. Okay, now the frequency at which the mass would oscillate was pulled 7 meters center. This has absolutely nothing to do with the problem. That's telling me the amplitude. Frequency doesn't depend on amplitude. Frequency is 1 over 2 pi times the square root of k over m. You just found k and I told you m. So you just have 1 divided by 2 pi times the square root of 16.333 divided by the mass, which is 0.2. So if I divide this by 0.2, raise it to the 0.5 power, which is the same as square rooting, and then divide that by 2 pi, make sure when you divide by 2 pi you put it in parentheses, okay, I get a frequency of 1.44 hertz. And finally, C. If the mass were pulled 14 centimeters instead of 7, how would the motion of the mass change? Frequency and period wouldn't. Okay. However, amplitude the distance it's actually traveling, the amplitude is larger. Okay, which actually means the vibration, the velocity of the mass is bigger. It's a little bit more. Okay. All right. Number 3, a 50 gram bottle floats in the water, bobbing at a frequency of 2.5 hertz. What's the spring constant of the water? Well, F equals 1 over 2 pi times the square root of K over M. You want K, so 2 pi F squared divided by, nope, not divided by, times M equals K. All I did there was I multiplied the 2 pi over, then squared everything. So I have 4 pi F squared. If I distribute that thing through, that pi is also squared, times M, not squared because it's not on that parenthesis, times M equals K. So I'm going to take 4 pi times 2.5, and remember this is squared, times the mass is 0.05, and I'll get my spring constant. So 4 second pi squared times 2.5 squared times 0.05, which is 12.34 newtons per meter. If a mass is added to the bottle, changing its frequency to 1 hertz, how much mass was added? Okay, so now I know the spring constant, I know the frequency, so I have 1, my frequency, equals 1 over 2 pi times the square root of K, which is 12.34, divided by my new mass M, which I don't know. Okay, so I have multiply both sides by 2 pi, so I have 2 pi equals the square root of 12.34 divided by M, square it, and so 2 pi. Now when you square 2 pi, guys, you have to make sure it's in parentheses or push enter first and then square it, or your calculator just squares the pi. Okay, I get 39.48 equals 12.34 M. Okay, so I'm going to take 12 over M. I've got to take 12.34 divided by 39, and I get 2.84. Well, that's wrong. 12.34 divided by 39.48 equals 0.312. I was like, what? My calculator erred. 0.312. This is actually kilograms. Okay, so that's 312 grams. That's the total mass. I asked for mass added, so you've got to subtract off the original mass minus 0.05, and I get 0.26 grams were actually added to this bottle. Okay, there is a worksheet today that reviews some of these problems, so good luck with that. Let me know if you have any troubles. Tomorrow will be a quiz.